Okay. Welcome, everybody, to today's Canada chapter presentation. Today's presentation is entitled Cybersecurity by Design. I just wanted to make a couple comments before we get into the presentation and then do an introduction. First off, I just wanted to say that we will be having an INCOOSE Canada chapter members meeting. This will be a very informative meeting. We encourage all members to attend. We'll be holding that meeting on June 27th, and you should be seeing an invitation to that meeting in the next few days. Today's session is going to be Cybersecurity by Design. We have Bob Pruska and Salome Wagner from Spark Systems joining us, but today's presentation will be by Christoph Schmittner, from the Austrian Institute of Technology. Christoph leads a team for system and security engineering at AIT. The main field there is safety and security in the automotive and industrial sectors. Christoph is a member of many committees, such as the Austrian Mirror committees for the ISO TC 22 road vehicles. And he's also a designated expert in international standardization groups. So this includes TC65, AHG2, which is reliability of automation devices and systems. And he's a project leader for the development of ISO PAS 5112, which is road vehicles guidelines for auditing cybersecurity engineering. So a very involved individual and very knowledgeable. So we're quite fortunate to have Christoph join us today. Without further ado, one last thing, Q&A at the end. So please hold your questions till the end. I welcome you to put the questions in the chat for this session, and I will read the questions out to Christoph, group them where necessary, and we'll try to address your questions at the end. So without further ado, please, Christoph, let's get into your presentation.
Thanks very much. Thanks for the introduction. Thanks for having me. I will start with an overview outlook about cybersecurity standards and regulations. So what do we have there? Why we have to be even more concerned about cybersecurity than we were before. And then a little bit about how we can address this with modeling with system engineering. While I'll be the only one talking, the work or the results I'm presenting is based on the cooperation between AIT and the Spark system, where Spark system is basically the experts in system modeling and enterprise architect. Regarding AIT, we are Austria's largest research organization, and I am from the Digital Safety and Security Center and working here on the previous mentioned topics. So mainly security engineering in automotive, industrial, railway systems, and active in many standardization committees here. If you talk about regulation in Europe, then the basic European approach to regulation is we want to have a risk-based approach. That means we have more or less very high-level European regulation with some basic essential requirements. And if the risk level is too high, then there should be a harmonized standard. That means a standard developed by some international standardization organization with more details, with technical requirement. And based on this, we can then assess if this product conforms. And the well-known example is the CE certificate. And there are two types. If there is no number, then this is based on a self-assessment of the manufacturer, of the importer. And if there's a number, then this number can be tracked. And this is a third-party assessment by some official authorized party. And besides the product level, we also need to have some conformity based on a quality management system. And this approach is there, it exists, it works. And the European Union tries to follow the same thing also for cybersecurity. That means there is a Cyber Resilience Act, And this defines the overall framework. So that means there are the essential requirements, the approaches, also this categorization I have shown here is defined there. And this Cyber Resilience Act will be required for all products with digital elements. This ranges from elements like software to elements which involve a digital component. That means smart speakers, that also includes toys, to microcontrollers, CPU, hard disks, so more or less everything which can be imagined when we think about digital elements. And the most important thing is that the whole approach follows a risk-based approach. That means if I want to bring some component with a digital element on the European market, I have to do a risk assessment. And this can be based on functionality, intended usage areas, impact if it's hacked. And then I have to classify my system into 3 categories. If I'm lucky, then I'm in the default category, and then I'm basically finished with this initial assessment, which can be done by myself, where I don't need to have some external consultant, and where I more or less only assess if the risks are too high, and if not, I can document the risks are okay, and I'm finished. For certain categories, or if the risk is above a certain level, then there's the class 1. Class 1 can still be managed by self-assessment, but this self-assessment has to be based on an international or harmonized standard. That means the approaches I follow, the procedures, the processes, the rating schemes, the requirements can no longer be based on some company internal guidelines, best practices, but I have to follow some international standard. And examples for this, for class 1 components are routers, microcontrollers, antivirus software, password manager. So more or less components where we expect a certain level of security. And then we have also the class 2 products. And there, a self-assessment by the manufacturer is no longer sufficient. That means there has to be a third-party assessment. Some external authorized organization has to assess my risk analysis, my security concept, also my plan, how I want to ensure that this system, this component stays secure in the future. So not only the initial situation, but also do I have some plan, technical means to update it, to detect vulnerabilities. And elements in this category are CPUs, smart cards, operating system. So more or less all components where we have even higher expectation on the security than for class 1. These systems here are only examples. So the classification should really be based on this risk assessment. And the classification, the following, if necessary, assessment and documentation will be required to be able to bring this element or the system on the European market. That means if I'm a manufacturer and I want to sell something in Europe, I have to do this conformity assessment. And in the case of a third party, there will be some official authorized organization, and they will do this conformity assessment. I will give them the order, and they have this approval of doing this conformity assessment based on some government authority. That means there is then some European or national body who approves certain organization to do conformity assessment, and they are allowed to check the conformity, the cybersecurity. And what they are checking is more or less based on the one side on the European regulation, but also on the standards. And obviously, the first thing are the security properties itself. That means, is the risk analysis complete? Are, based on this risk analysis, unreasonable risks managed? Meaning, do I have some security controls in place? Do I have some risk mitigations? Do I have some documentation traceability from risk to security control to security testing, which demonstrates what I did and that this security control is also efficient? And then also how I want to handle vulnerabilities and how I want to handle incident reports. The whole development of this standards on the one side is not only for the notified bodies for the conformity assessment, but also for the manufacturers. So they have to follow these procedures, otherwise they will not be able to demonstrate compliance. And they're developed by the standards developing organizations and approved by the European Union. And in the end, if everything goes well, I have a declaration of conformity that proves, yes, this system is secure, it's classified in this and this category, and I have the according technical documentation. That means all of the stuff which was assessed, either in the case of class 1, class 2 by myself, or in the case of class 3 by the external authority. If someone wants to go there into more details, the whole thing, there's also more or less a regulatory framework. So the most important, obviously, is the Cyber Resilience Act. This is based on a Cybersecurity Act and on a NIS2 regulation, and then there are also regulations for the CE marking. But more or less, this is how cybersecurity in the future in Europe will be handled for all digital products. There are some sectors where there are already more requirements and established processes. I picked out here a few where I know that there are already some requirements. So energy sector, medical, railways, automotive, they already have part of this approach implemented. And the idea is that these standards and regulations will be sector specific, but that they will fit into the overall approach of the Cyber Resilience Act. So there shouldn't be any difficulties in following the Cyber Resilience Act if I followed some sector-specific cybersecurity regulation. And as one example, what I mean with sector-specific, I've picked out the automotive domain because I'm active there and because I have a good overview and knowledge about what's going on in this field and what requirements and developments are there. And if you talk about automotive cybersecurity and regulation, then it's important to address that this is not only a view on Europe. So most nations follow the UNR type approval process, and there the UNR 155 is the cybersecurity relevant regulation. Brazil and China have a little bit different approaches, but also are regulated. And then I also included the US and Canada, which don't have a regulation. There is some plan for a regulation in Canada. So they have guidance and they have a strategy document where they have at least a plan for regulation, but so far there is nothing really required as a regulation. Similar, it's in the US. They have some best practice guidance document, but no regulation. China has here a very strict plan how they want to develop automotive cybersecurity. And they also plan to adapt the European and the general, the UNR regulations into their regulatory framework. In China, we also see a more or less similar approach like the European regulation. So there is a law which is on a higher level, then there are some regulations, and then how to implement these regulations, how to address them. This is then handled in technical standards, in more detailed technical documents. As at Brazil, this regulation, it includes automotive systems, but it's not solely for automotive system. It's more or less for all systems with any internet connection capability. That means it's somewhere in between the European Cyber Resilience Act and the more detailed UNR Automotive Cybersecurity Regulation. And it's similar. There has to be a certification and a market supervision. And if there is anything going on, so basically if the cybersecurity is not as strong as claimed, then the product can also be pulled back from the market. For the UNR regulation, for the cybersecurity management system, this follows more or less also this high-level approach. So we have a set of cybersecurity principles. We have requirements on the cybersecurity management system, and then we have to address cybersecurity on a vehicle level. Again, with a risk-based approach, that means we have to do a risk analysis. We have to determine which risks are acceptable, which risks are not acceptable, and then we have to address the unacceptable risks, document the whole risk management, and show this documentation in order to bring our vehicle to the market. And that means, to make it a little bit more visualized, first thing is we need to have this cybersecurity management system. This has to be certified every 3 years. And then we can get a vehicle on the market. And for that, we need to have the cybersecurity type certification. And we have to have this cybersecurity management system certified. And this has to be done for each vehicle type. Again, we have the European law, we have the regulation, and then we have the standard. And they are all connected, interacting with each other. So the standard defines the cybersecurity case, which is this whole connection from system architecture to risk assessment, to security controls in the system, to testing. And that can be used as evidence for the type approval. And then there is also some guidance on how to assess this whole system. And on slides, all of this looks quite nice and good defined, and it will work out. In reality, if you go to the technical systems and to the systems and to systems engineering, this is a huge task. Because if we talk about modern cars, modern systems, they are complex systems. They are most often not completely developed from scratch, but based on existing systems which we are adapting, where we are implementing some variants, some changes, and having to redo our risk assessment for each of these variants, having to address the cybersecurity, having to demonstrate all of this for each variant is a quite challenging undertaking. And therefore, we said, okay, good, there has to be a better way to do cybersecurity for such systems. And our wish list would be, we want to have some vehicle architecture. We want to be able to have this vehicle architecture in a model. And the nice thing, what we want to have is, we want to have something which takes this vehicle architecture and tells us, okay, good, I checked this vehicle architecture, and there in this system, someone would be able to attack it and cause some chaos. And then you can think about how can we address this. And after we have addressed this, we can redo the analysis and we can then check, okay, good. Is there still some attack possible, or do we have a good security concept? And if we have it on such a nice level with our system model, we can easily connect all together and we can easily say, okay, good. We have this risk analysis. This risk analysis resulted in this potential attack. Therefore, we implemented a security control, and this security control proves that we address this risk. And if we have it in a model, we can pull all this information, give it to our third-party assessor. He can assess it, and he can tell us, okay, good, your security is sufficient. That would be a nice thing to have. And basically, this is also where we worked on what we did, where hopefully I can give you also some live demo of the whole thing and how it works. To give a little bit of an insight, so we have a system model and we derive some threats for the system model. And this first step is based on a database of vulnerabilities which are formulated as rules. That means they describe some abstract scenarios, configurations, situations in systems where an attack or vulnerability could be exploited. And this we use to derive an initial list of threats and to then define some initial security steps. These vulnerabilities, these rules are not only described, they also are connected. So we have for each of them, we took here more or less a page out of systems engineering, out of contract-based design. Each of these rules has a precondition and a postcondition, meaning we also can derive this nice attack paths, attack trees, how an attacker can move through our system. And with this, we can iteratively, automatically analyze our system, derive some potential attacks, and see what we have to change in order to stop an attacker, in order to secure our system. And now, live demos are always a little bit challenging, but hopefully it works. Let's switch directly to the implementation, to the tool itself. It's implemented in Enterprise Architect, therefore also this cooperation here with Sparks, which are the company for Enterprise Architect. The modeling language itself is more or less based on SysML with some extensions like this trust boundaries. And modeling is quite simple. I take a component. If I double click it, I have some security properties this component can have. So on the one side, we have things like hardware-based security. That means, is there some physical protection against an attacker? This can range from the system is difficult to open to if we go here on a strong level, there is some sensor internal, and if someone opens the system up, then this intrusion is announced to some management system. And similar, we have also other security properties. If there is some secure boot, if I can update the system, and if I can do this update either without any security check, with a simple secure checksum, or if the update is encrypted, I can add to all of these components the ports. That means basically has the system some input-output. And for these, I also can define, are they authenticated? Is this an input-output? Is this wireless or is this wired? And all this information is taken. And if I go then on the analysis, I basically have a check against the database of threads, and I get some overview about what attacks would be possible. So we have here this connection between the data center and the first vehicle internal system is wireless. And I defined for this architecture no security properties. And so we see here, this could be hacked. These elements are affected. That is the impact. I can change the impact. And we have here on the one side quite easy attack visibility, but we can also configure it to more complex approaches where we then have really enumeration between, okay, how long do we assume an attacker needs for such an attack, what expertise is needed, what knowledge about the system is available, how long is the system accessible from the outside, is there some specific equipment needed? And we can then define what risk treatment do we want to have. So basically we could say, okay, good, this connection, it only happens after it's initiated from the vehicle. So basically this is not consistent, but this is something where the vehicle owner has to initiate the connection, and therefore this window of opportunity is very low. So we could say, no, I have to see. This is always the issue with live demos. It seems that I'm writing in the Zoom chat, but not here. But yeah. And this way, we can also say if we want to not accept this risk, but if we want to treat this risk, we can, for example, define here that this connection should be encrypted. Could say, okay, good. We want to have here at least a moderate encryption. Obviously, besides this single attacks, it would be also interesting if an attacker is able to reach some critical components. Critical components for us are denoted with assets. That means this component has something which is of value, which we want to protect. And here in this example, we want to protect the integrity of this control unit, because if an attacker would be able to change the operation, the safety could be affected, and we would have at least a moderate safety effect. And if you want to know if an attacker can reach this asset, we are interested not in a simple analysis which tells us all the threats, but we are interested in an attack tree analysis. And that means the system tries to go through this whole list and tries to find out, is there an attack on this element possible? So could an attacker move through the system and access this element? We have here a more or less well-defined toolbox, which covers, in this example, for the automotive domain, most of the elements. But obviously, we know that there are some specific elements, that there are some specific components where someone wants to extend this toolbox. And here we are believing in cooperative work, in that in security, you want to have different people looking at your system, looking at your security analysis, and therefore this toolbox is generated based on the information in the ThreatGain backend. That means we have here the same toolbox with the same elements, and if I want to add an element, I simply add it here, give it a name, give it a description. I can add here security properties I want to have. And when I restart EA the next time, this element will be in the toolbox, and it will not only be in my toolbox, but it will be in all the toolboxes of the people who work on the same instance. So we have the different instances, and if you work on the same instance as someone else, you have the same toolbox available. Not only the same toolbox, but also the risk calculation will be the same and can be defined here for all working on the same instance. You will have the same set of security threats. You will have the same set of security controls. So all of this is not specific for one model, for one diagram, but it's based on this backend where we can define what elements you want to have, what rules, what risk rating, because otherwise, if I would modify my risk rating and then classify, define the risk treatment based on my risk rating and give this analysis to someone else, he would be more or less lost and would have no idea why I come to these decisions. So therefore, it's quite important that the elements, security controls are the same for all. Personally, I would be happy if the further work is always done model-based. So if there are the security controls you have defined here, defined as requirements, and if then the further implementation is also done. But we know that many companies are still working with less model-based approaches, and therefore we can also export the whole model and the whole list of security controls, security requirements connected to the threats as a Word or Excel report. In order to support collaboration, if someone is not using a model-based tool, if someone is not using a requirement management tool, we can export the requirements connected to the risks as an Excel, and he can use this and work with this further. And we also can show a summary, which is also included in the Word, about what risks we have, how distribution of impact and likelihood is, to more or less give a quick overview about how secure is our system. And this is now more or less the additional functionality which comes through ThreatGet. The nice thing in basing this whole plugin on an existing model-based tool is that classic model-based engineering. That means defining for some element a child diagram where I want to model the internals of this element, or also reusing the whole diagram in an additional development and making a variant and linking the components from this diagram in another one can be done quite easily. So basically, we have here on the one side the whole security analysis, the whole security engineering integrated into the system engineering, but we are also able to still use the benefits from system engineering. We are still able to more or less use what system engineering gives us, what they already developed, and extend this towards security. Obviously, the whole thing is only as good as the underlying knowledge about risks, about threats. And there, this is now after the whole bracing ThreatGet, one thing. So for the automotive domain, we have a very good database. We also have for the industrial domain a very good knowledge base. But for other domains, we have relative generic or high-level databases, which can be used in the concept phase, which can be used for some initial assessment, but they are obviously less maintained. this is more or less a point that we decided we want to focus on these two domains, because the automotive domain, they already have this cybersecurity regulation, they already have this cybersecurity challenge, and the industrial domain, if you look at this Cyber Resilience Act, most industrial systems are at least class 1 or class 2 systems. So for them, there's also a big need to address this security and to increase the efficiency of security engineering. Especially if you want to redo analysis, if you want to redo a variant of your development, doing the analysis manually again and again is very time consuming, and therefore we think there has to be a way which is based on modeling, which is based on integration with system engineering, and we have to connect from security engineering to system engineering to modeling in order to increase the efficiency and to address the security requirement and the security regulations. Some little bit more marketing. So the whole thing was also awarded a few nominations and prizes in the last year. And to sum it a little bit up, so for us, the most important thing is security has to be aware of the domain where it's applied. So there is no one solution for all security needs. I have shown the example of the hardware-based security. If we talk about IT security, about security for web-based solutions or server solutions, nobody will talk about hardware protection. If you are in the field like industrial, automotive, railway, the protection of the systems against physical access plays an important role. We need to have a diverse view on cybersecurity. That means we have to be aware of hardware-based attacks. We have to also consider attacks on cryptographic algorithm, on software, on implemented update mechanism. The whole security has to be connected to systems engineering, to modeling. One of the reasons why we started the whole ThreatGate was our involvement in security analysis and our frustration with having to check with the system engineers before we did a security analysis about their changes, and having to use more or less half the time we aligned for security to be aware of what was changing from a systems engineering point of view. And we have to have this traceability. Otherwise, it will be impossible to certify a complete vehicle or a complete industrial system. Cybersecurity has to be traceable and has to be connected to the system and integrated into the standard requirement management. And we have to have this traceability from risk to security control to security testing. And obviously, I don't think that the security expert will be out of work with ThreatGate. Basically, if you look at the Cyber Resilience Act, I think security experts will be in very high demand. But in our opinion, security experts should work on solving the security, so designing a good security concept, but not on doing security analysis the 100th times for more or less a similar system. This information about what attacks are possible, what weaknesses are in the system architecture, they are similar in one domain, and this information should be automated and should support the security engineer, the security expert in focusing on how to solve security. So thanks very much from my side. I'm looking forward to your question and to the discussion. And also, if you are interested in testing the tools, we offer evaluation and demos. So basically, there, I think I'm also quite happy if you say, okay, good, that sounds interesting. I don't want to buy it, but I would like to test it.
Very good. Thank you, Christoph. That was a really good presentation. We've got a few questions, so we'll dive right into the questions. So one question is, can this example, the example that you went through, is that available through, if looking for example, a trial license, would you also get some examples, including an example that you had shown here today, or are there other means of getting examples for our for users to play with?
Definitely. So we have included multiple examples. If you add here a new diagram, so I have to shift always back from the other window. There we also have the base set already includes an example. So we have this, which is an empty, because we think it's important to see how it's done and to have something to start to play around.
Okay, yeah, it's always good to kind of get that start. Okay, we have a question about ThreatGet and whether it's only available for enterprise architects, and do you have plans to integrate with other model-based development tools?
There are some discussions, but currently it's only available for enterprise architects.
Okay, good. Yeah. The first question that came in was, what class would medical devices fall into? So there's the class 1 and class 2 with where you can self-declare or need third party. Where would medical devices fall in?
So medical devices are never class 1. They're either class 2 or class 3. Main thing is if they are actively involved. So if we talk about the medication device for insulin, if you take about some pacemaker, this is always class 3. If it's only a device which detects things, so for example, to measure your heartbeat or stuff like that, this is class 2.
Okay, yeah, that makes sense. I guess if it's sort of life-threatening failures or life-threatening, that would make sense. We have a question here from Munish. Could you please elaborate on why there are no regulations in North America at this time? Guidelines, I think you've mentioned for Canada, but why is North America kind of lagging Europe and China and other areas?
I think on the one side, it's a little bit a different approach. So in Europe, you have to have this pre-check before you go to the market. And in the US, you have more, if something happens, then you have consequences, but not before. On the other side, I had there some discussion with an American lawyer, and his reasoning I found very interesting, because he basically said it doesn't matter if there are no US regulations, as long as there is a European regulation and this is used, most US companies, bigger one, will also follow them, because if there is an incident and if you are before a jury and the other side can say there is this European regulation, and if you would have followed them, this would have not happened, you will lose.
Okay. So,
his example was the Toyota self-acceleration.
Right.
They never found really an issue, an error, but they checked the software code and they could declare that this is not MISRA C compliant. MISRA C is a standard for automotive C software. And basically after this evaluation, Toyota decided to pay.
I see. Okay, so kind of a supporting due diligence, I guess. That's very interesting. Yeah, thank you. Ken has brought up, I think, a very good point. So with standard-based approaches, potential attackers are aware of the standards as well. And so potential attackers will know what equipment manufacturers are designing too. So how do we evolve our system security implementation to cope with these attacks, where the standards are going to lag typically the attacks, the new attacks as they surface. So how do we evolve our system security implementation to ensure that we're addressing what's on the horizon, I guess? And what are your thoughts there?
This is a very good question, and also one of the weak points in standards. So first thing, I know that there is currently a huge progress or a huge plan to progress in more or less all standardization groups towards faster standards. They see that it's not only cybersecurity, it's also other emerging topics like AI, where they see that the standards are massively lagging behind the technical progress. And they try to become faster in the standard development cycle and try to improve this. This is the one side, but obviously standard development will never be as fast as the technical progress. So in cybersecurity, this is partially addressed, that if you look at the technical solutions, at the vulnerabilities they force us to consider, there is always now this statement included. This is more or less a starting point, and you have to also demonstrate that you are aware of new vulnerabilities, that you have processes, connections to security sharing groups, and can demonstrate that you are looking at security not only as a static thing, but as an always moving target.
Okay, no, that's good. Now, an extension to that, you had a slide, Christoph, that showed for automotive and for industrial, all of the standards that are part of the ThreatGet knowledge base. Now, so do you mentioned the standards, but then there must be some addendums and et cetera to the standards and these other resources. I guess you have external resources there in the middle. Okay, so how in terms of how current, I guess, how often do you update this knowledge base and make it available to the users of ThreatGet?
So we normally aim to have at least weekly updates. Very in the beginning of all of this, so the initial knowledge base was really done by hand. Now we have I would not call it AI, because this is a little bit too high spoken. It's a natural language processing tool, which basically looks at security sources, security information, threat intelligence, and translates this threat intelligence into ThreatGet knowledge base entries. Because we see that we might be able to review the entries of this NLP algorithm, but really keeping track of all the available sources and all the available information, this takes too much time. We would not be fast enough to really provide security information and updates. Okay.
Yeah, no, that's good. Further to that one, I'm just going to continue with some of my own questions. Please, anybody add your questions to the chat, and we'll get to them. But now, okay, further to what you just said, Christoph, and that actually is quite impressive. This is, you know, your process for capturing from the text, I guess, just to capture the necessary information for your knowledge base. Now, what about vetting? This isn't really a threat get question necessarily, but how do we vet all of this data in that you gather? I guess where I'm going with this is there a possibility that these bad actors, the attackers, is there a possibility that attackers could embed backdoors into the standards, into these other knowledge bases wherever they exist? How do we prevent that occurrence? Did that question make sense?
Yeah.
Okay.
Obviously, such standards and vulnerability databases are quite interesting targets. Regarding standards, I know that there were some discussions and also some observations where it was detected that proposed algorithms or security controls had weaknesses, and it was obviously never really proven, but at least assumed that these weaknesses were purposely integrated. So far, in standards, the more or less consensus-based approach, that means technical experts from different companies, different governments come together and review and work on them, hopefully ensured that it was not possible to really publish such a standard. So we know that there were some proposals which had weaknesses, but these weaknesses were detected, and we don't know from a published, approved standard that still had weaknesses. Either the process is good or the bad actors were really good in hiding their weaknesses.
Yes, right. Yes, I can imagine that being a challenge. Let's see, Rich has a question. So Rich is asking, but are there options for import and export of the model data using Excel or a CSV format?
This definitely. So this is for us one of the benefits. So when we started development of ThreatGet, we thought for a short time about doing the whole tool, including the threat model or including the system modeling on our own. The benefit in relying on enterprise architect is that we can use their existing import-export features, that we are able to import models EA can import, that we are able, so there is, for example, if we talk about DOORS or Polaris Requirement Manager, there's an export from EA to these tools, and also other modeling or other diagrams from other modeling softwares can be imported, and this is possible.
Okay, good, thank you. See, another question just came in from Trey. Can you use your process if you do not yet have a system model? For instance, if you're in the conceptual design phase and you just have an early ConOps with high-level system functionality, can you use that with ThreatGet?
Yes. So therefore, I also mentioned this possibility to derive subdiagrams. So typically, we start on a conceptual level with more or less functions and signals, data that is exchanged between this function, and conduct here the first analysis, and then we map these functions on building blocks of the system, and then we define for these building blocks the architecture, where we say, okay, good, we have this function and it has to communicate with this function, and we map this function on this component and this function on this component, and that means the signal has to communicate between them, and there is this communication element in the system architecture.
Okay.
The level of detail will differ for the results. So, for example, if you have a conceptual diagram, we will have a threat that this signal could be manipulated. If we know that this signal is only communicated in our system and not with some external system, so if we have some details, the results will be more fine-tuned. And if we know that this signal is communicated over a certain protocol, we can really show, okay, good, this protocol version has this potential vulnerability. So the level of detail of the threat get results mirrors the level of detail of the system engineering.
I see. Yeah, I can see that as, and you had shown it in that that one cyclic diagram. I could see it being an iterative process, regardless of how high you start. As long as you have a system boundary and you understand your interfaces, I guess you've got a starting point, right?
Yep.
Yeah. Okay, so Ken has another question. So and states it as an obvious question, but how does your tool evaluate or measure resilience to cyber attacks? Do you have any specific metrics?
So resilience is quite difficult, because resilience is defined in many ways. And one of them is how good a system can operate while cyber attacks are ongoing. What we have there is that with the assets, we can define how critical certain functions are. And that means we know if a cyber attack is ongoing and the cyber attack would be able to attack these and these components, then the core functions of the system would still work, because the systems are more or less important, but not important for the core functions. They would be important for some comfort or nice to have functions. So in this way, we can derive how well a system can cope with cyber attacks. Resilience is also used partially to show the resilience against cyber attacks. And I showed in this configuration the different strengths of the security control. And if we go towards encryption, then we see there that weak, for example, is a simple secure hash. So that means the encryption is not protecting the readout of the data, but the manipulation. Moderate is something where we say, okay, good, this is a symmetric encryption. It might be possible to break it, but basically you cannot change it. You can record the message, you can break the encryption, but you are not that fast that you are able to change this message in real time. And strong is then something where we say this is currently computationally not feasible. And in the rating of the likelihood, we take this strength of the security control into account. That means depending on how strong your security concept is, the likelihood of successful attacks will go down. Obviously, this is a balancing between the resources you want to spend on security and the likelihood, or the risk level, what you're willing to accept.
Yes. Yeah, I guess the consequence and severity has to be taken into account. Very good. That's the last of the questions I see here. We'll maybe just give half a minute here to see if anybody enters another question. But I'd like to thank you, Christoph. This was a really good presentation. You know, it was nice to see the tool and how it integrates with EA, but you gave us a lot of background as well. And so I think all of us have learned a little something. There's one last, Jack Stein had provided some information here. He just wanted to point out that the INCOOSE Critical Infrastructure Protection and Recovery Working Group, the CIPR Working Group, monthly presentation is at 3 p.m. today, Eastern Time. The speaker is Michael Hoover. He's the program coordinator for all hazards analysis, or AHA capability in the CIPR. Or CISR, sorry, division of the Idaho National Laboratory. So the flyer can be found with a link that Jack has provided in the chat. So if you're interested, again, 3 p.m. Eastern Time today, please take a look at the chat and you'll get the link to attend, to register for attending. But thank you again, Christoph. Sorry, go ahead, Jack.
I just wanted to say that that's a big topic is cybersecurity with that CIPR working group. And I just saw in the news there's a global cyber attack going on right now.
Mm-hmm.
Breaking news: Europe, the U.S. Looks pretty bad.
We better let you go, Christoph, so you can help solve that.
Good idea.
Yeah.
Yeah. All right. Yeah. No, thank you. I'm going to look into that, Jack. Very interesting. And it's an ongoing topic in every industry, really, right now. It's cybersecurity. Thank you, everybody, for attending. Again, for those who are members of the Canada chapter, please put in your calendars that on the 27th of June, we're going to have a member meeting, and we're going to be welcoming input from all of our members. We really encourage you highly to attend that meeting. So you'll see an invitation coming out in the next several days. But with that, we'll close for today. Thank you, Christoph. Take care, everybody, and have a good remainder of the day. Yes.
Hello. So
Hello.
you mentioned
Hello.
So you mentioned the 3 p.m. meeting. I click on the link, but it's not working. It shows like the 404 pages now found it.
Oh. I tried clicking on it, and I did get. I just did that just now, and I was linked right to the flyer for the meeting. And there's at the bottom of the first page, there's a Zoom meeting link. It seemed to work. Maybe try copying that text into your browser. If it's not working directly.
Yeah, it should. I think it's working. Yeah. Might be something with the browser, with your browser.
Yeah.
Okay.
Okay. Hopefully you'll be able to get to it.
Okay.
All right. I'm going to stop the recording and end the meeting. Thank you, everybody.
Was there contact information provided to find out about a demo or a trial?
Christoph, are you able to comment on that? If individuals are interested in a demo or to get a trial license, what is the process?
So best thing is to contact Spark System. I will send the email to you, or basically, I'm not sure if Bob is still here, but I think the best thing is to directly contact Bob, and he can distribute them the access to the demo and the trial.
Okay. We'll try to get that information and post it along with the recording. Sorry, somebody was trying to say something. Was that you, Jack? Okay. Thank you, everybody. Take care. Have a wonderful remainder of your day.